Functional notation is a notation that is reserved for equations that are specifically functions. So once we are confident that the set of ordered pairs we're looking at is going to be such that each x generates only one y value, then we can use functional notation to represent the equation. But in order to do that, the first thing that we need to do is solve the equation for y. And when we do this, we'll just double check and make sure that it is a function. And once we have it solved for y, then we're going to replace that y value with this notation here. So let's just take a quick look at this notation to say that f of x is how this notation is read. We say f of x, these two quantities are essentially one symbol. It's not f times x, it's not anything that can be separated from each other. It's one symbol that goes together, and we read it as f of x. So here we have an equation that is a function, and we're going to want to write it using functional notation. Well, again, the first thing that we want to do here is solve the equation for y, and in order to do that, we're going to isolate the y value by subtracting 2x from both sides. We have negative 3y is equal to negative 2x plus 6, and then we'll divide both sides by negative 3, and get that y by itself on the left is equal to, now we'll say this is going to be positive 2/3 x minus 2 after we reduce both of those fractions. So we have solved the equation for y. Now once we do that, we're going to replace y with f of x, and let's write that in a slightly different way. It means that the y value and the value or the notation f of x are going to be equal to each other. They're interchangeable, and when we have our equation solved for y, we're going to be able to essentially replace that y with its functional notation counterpart. So that y just becomes an f of x, and then we have the right hand side of the equation that's just copy pasted down, and this is our function written using functional notation. So here we have another example, and we want to write this equation using functional notation. And again, our steps are going to be to first solve for y, and then we're going to replace that y with our f of x functional notation. So solving for y here, let's subtract x squared from both sides, and we end up with negative 4y on the left hand side. On the right hand side, none of those are like terms, so I'm going to just copy paste all of them down in descending order. And then now we will divide both sides by negative 4, and we need to divide everything on the right hand side by negative 4. So this is going to be y is equal to, we need to ensure that that negative 4 is divided into all three places in the numerator here. So that's going to be positive 1/4 x squared minus 2x plus 1/2, right? That negative 4 is going to be divided into every term in that numerator. And now that we have solved for y on the left-hand side, we're going to simply replace that y with the functional notation, again, that reads f of x. And so we've got f of x is equal to 1/4 x squared minus 2x plus 1/2, and that is going to be our answer. This is the equation written in functional notation. And again, this functional notation is reserved for functions, meaning each time that I plug in an x value, I'm only going to get one y value out as an output.